Hello there, and welcome to another episode of All You Need to Know with your host, Saranya Gopinath. As always, the AI world is bustling and there's a lot to catch up on. And today, we are going to be talking about the model story. We are seeing different sizes of models, different philosophies of how they are released, and even the way that they are accessed is now on a spectrum. Now, before Claude releases yet another feature in the 20 minutes it takes to finish this episode, let's dive right in. So, in a matter of about 10 days, like around mid to late March to early April, there were two major models that were released and really shook up the AI world. Had everybody talking, and everybody's opinions were all over Twitter, LinkedIn, you know the works. It was Gemma, released by Gemini, and Mythos by Anthropic. Now, they are on distinct ends of the spectrum. One is on size, but also the decisions they took on how all of us can access and work with these models. Before we get into what each of these are and why these decisions were taken, I do want to touch upon the concept of model size and why that's really important at all to the way that we understand and consume models. It's really important. A lot of these things are, they're takeaways to the larger story. So let's dive in. The size of an AI model refers to the number of parameters that a model is composed of. So think of parameters as billions of little dials that the model is learned to tune while training. The more the number of dials, the more detailing and nuance it can hold, and that results in the detailing and nuance that you interact with as a user. So of course, as we know, ChatGPT, Claude's Opus, Capybara, they're all large models. And how we know them is, of course, as large language models. They have billions of parameters, really expensive to query, requires a lot of compute infrastructure, as we've discussed earlier, and they are built on substantial general intelligence capabilities. These are distinct from the small models, like, of course, Gemma. They're sometimes known as edge models. About 2 to 4 billion parameters to be distinguished from around almost trillion parameters the large language models now are coming across. Edge, because they're small enough to live on your device, makes it cheaper and easier for compute power and access. And of course, the capabilities, while started off as more niche, are now growing. And those are some of the advancements we're going to be talking about today. Also, now we want to get into how do small models come about? We understand how the larger models work, but how do the small models really work? Because if it is really cheaper and more efficient, then the logical thing would be we should all just be building smaller models, right? And that's where the answer is not that simple. There are several methods by which small models are built, and there are different processes that are involved in each of them. Let's go through them one by one. One is called quantizing, where the models are built by reducing the precision of the parameters. So for example, a 32-bit integer is replaced with a 4-bit integer to reduce the size. Another model or another method is pruning, which essentially happens by identifying parameters that contribute very little to the end output, effectively pruning the dead weight inside the model, which really doesn't impact or contribute substantially to the output. Now, one of the most effective methods of building a small model is, of course, the knowledge distillation method. This is where a smaller student model is trained by the larger teacher model. Essentially, a small model is trained by the output of the larger model. The catch here is, of course, that the smaller model has a ceiling. It cannot be better than the larger model that it learned from. So in creating these smaller models, there is a core dependency. The smaller model's existence is dependent on the larger model. We can understand this by the concept of sachets, like small sachets of shampoo. Hear me out. So if you think about the way that the large companies like an HUL or Click created the small sachets of shampoo, it was after they created the large systems, the factories, to actually create their flagship models, in this case, the larger bottles of shampoo. So in some sense, the sachets were a smaller representation and always downstream from the creation of the large bottles of shampoo. Small models, downstream, large models. But of course, now you have to say, Sarnya, obviously that analogy breaks down because surely you can just create shampoos for being sold in smaller sachets. It doesn't always have to happen off the bottle. And in theory, you are correct. there's a pricing and all of that story, but in theory, it's possible. And similarly, in theory, you actually can create small models from scratch. And it was explored with the Phi 1 and the Phi 2 models released by Microsoft. These were very high-performing small language models that were created by generating very high-quality data and using that data to train the model. It was called textbook quality data and was captured in a paper titled Textbooks Are All We Need, a nod to the title of the original Transformer paper. And at this, Phi, with just 1.3 billion parameters, was able to outperform models more than 5 times its size. But the catch here is that while it was indeed built from scratch, it also had a dependency on a large model, in this case GPT, for creating the very curated, high-quality data sets that it was trained upon. So in some sense, the dependency doesn't go away. The point at which it is and the manner of the dependency is what changes, and that also impacts the output. Think of it this way. Distillation, the knowledge distillation method, is like having a master chef training an apprentice and having them watch and replicate. Phi, or this textbook learning model, is more like watching the master chef after they write a cookbook, and the cookbook now can be taken everywhere, and that cookbook is what you train and learn on. There may be a difference in quality between the end student or the apprentice who learned by watching the chef and the person who's learned by reading the cookbook, and that's kind of the direct and indirect methods of learning that we have to understand are the dependencies of the knowledge distillation and the textbook learning model, respectively. All of these decisions impact output, and as a result have to be taken into consideration when we decide the learning model we want to pursue. Okay, now with this understanding of the difference between large, small models and the impact, let's go back to the headline. Gemini released the small and very effective model Gemma, and Mythos was released by Claude, a model so powerful that they are refusing to even make it public. Let's take this step by step. What is Gemma and why is Google doing this? Gemma is a small language model primarily, but it also comes in 4 sizes. A 2 billion parameter one that is small enough to live on your phone, and a dense 31 billion parameter one that ranks 3rd in world performance. Gemma is released under the Apache 2.0 license, which is the most permissive license that a tech company can possibly utilize. It means you can modify, freely use, and even commercialize all the instances that you create of Gemma. Gemma is also really powerful. It supports over 140 languages, natively processes videos and images, and runs completely offline on Android devices. Now, obviously, this shorty has its limitations. It still is outranked by some of the best closed models in robustness and richness. And for higher stakes, more complex processing, let's say legal matters, medical analysis, multi-step strategy, the gap remains between Gemma and even, let's say, its own frontier models. But all in all, it is a very effective tool for multiple use cases, like deploying on local devices, in deploying in offline scenarios, and has over, I think, 100,000 use cases at this point that people have downloaded and used. So imagine if you're looking for models for deploying in a school which has not such great connectivity at, let's say, a remote village in Indonesia or the Philippines. Gemma would be very, very useful for that. Also, if you want to have your own sovereign, privacy-preserving versions of it, that is also something that you can do, because then it becomes a completely localized model within your control autonomy. And all of these are absolutely brilliant use cases for, in sensitive sectors and so on. So why exactly is Google doing all these amazing things? Out of the goodness of their heart? I mean, these are the people who have maps out there offline and free, but this is definitely one of those long-term Google games. One of the reasons, the first would be the upgrade cycle. Gemma 4 is great today. The Gemma 5 will be better, and you will come back for it because your competitors are using it. It's not unlike the way that, people, when they try to build on Chromium or they try to build on Android instances, they keep coming back for the next use case, even though it's all free. The scaling. Now, this is interesting and is a very Google-specific play. Now, while an individual developer can deploy this instance of Gemma on his laptop and has complete freedom, and that's very much true, A startup, when they try to do the same for their use cases, will hit a ceiling in terms of infra, right? When they start to have millions and millions of customers, that really can't be supported by the infra on your laptop. And this is where it's really smart, because the pathway from local fine-tuning to production level on Vertex AI and TPU accelerated serving is built into the product. So once you have Gemma, the rampway to using Google Infra like Google Cloud is easy and available. And that's usually what will end up happening. Effectively, at scale, it activates. And the last is, of course, the standards play. In some sense, Google is like the king of this. They've done it across various products where they are like the open source king. At this point, with over 400 million Gemma downloads and 100,000 variants of it since its real launch, Google is looking at some real proliferation. They want it adopted, they want it to be utilized by everybody, and they are encouraging all of you to run at your own local instance of Gemma. Now, if Gemma becomes the dominant open model architecture, it can shape the way that AI is built, what developers expect, what hardware gets optimized, and the entire universe. Google effectively gets to set the vision for what OpenAI looks like. That's huge, and that's kind of Google reclaiming its throne. With that, let's jump to Mythos, right? What is Mythos, and why is Anthropic gatekeeping it? Mythos, part of Anthropic's Capybara series, is Anthropic's newest and most powerful model, which is not released to the public. In fact, it's only been released to 40 handpicked organizations under Project Glasswing, specifically to analyze it for cybersecurity work. Why and what exactly happened? Why is such a large company holding back its most powerful product? So effectively, what happened was that once they started testing on Mythos, they found capabilities that they were not expecting and far exceeded their expectations. For instance, Mythos was found to identify and exploit zero-day vulnerabilities, which is effectively never before seen vulnerabilities, on virtually every major operating system and every major web browser out there. Basically, it was able to exploit capabilities or vulnerabilities in system on what you are watching this, on what you are running on your phone, the works. For context, the last public model by Anthropic found 500 vulnerabilities on open source software. Mythos found tens of thousands. That is at scale, an exponential scale uptick from where the last publicly available model was. Now, this is where things get nutso. Anthropic didn't train Mythos to be like this ultra cybersecurity hacker. These are just the effects of the general improvements it made. So the way that Anthropic tries to continuously improve its models on reasoning and autonomy, that ended up becoming this tool, which was this ultra cybersecurity hacker. The same intelligence that made it a better assistant also made it a better attacker. And that's why we need to be watching this very carefully. To be fair to Anthropic, I do tip the hat to them looking at this very objectively and seeing the possible downfall or the risk that this could expose if released in public. This is the first time in the recent past, or at least that I know of, where a large AI company has publicly withheld a model for safety concerns, and safety concerns that they themselves are declaring and having conversations with and looking at very constructively. I do completely appreciate the direction that Anthropic has taken on this and the way that they're trying to find solutions, the way this goes forward. This is clearly no longer a conversation about benchmarks or the kind of metrics that we used to do for efficiency tools anymore. This takes on a whole new scale and meaning. In fact, things got so dramatic that this triggered an emergency meeting by the Treasury Secretary of the US with their Fed chair and a whole bunch of Wall Street CEOs to discuss the cybersecurity risk of Mythos. And in fact, even as of today, there is a convening in Washington where the Pentagon is having discussions with Anthropic to understand the cybersecurity implications of Mythos. Okay, so this is the scale or the backdrop of what we are now living in, right? There is the Mythos, there is Gemma. What is our takeaway from all of this? These are seemingly two completely distinct and almost divergent advancements. And yet, they're telling you the same thing from two different directions. Gemma shows that intelligence can be distributed. It doesn't all have to be attacking like 5 cloud compute centers sitting out of Ireland or Texas. The frontier doesn't have to live out of a data center in California. It can live on a phone, in a classroom, in a remote village, in any part of the world. The last mile is now genuinely reachable and is now within your autonomy. That is huge for the number of models or the number of ways in which we want to see AI start impacting our lives. Mythos, on the other hand, shows that once intelligence exists, it cannot be fully controlled. The same capability that made it better as a model to just assist you in your life is making it a stronger and better attacker. Safety and capability are not two distinct dials that you can tune independently. They are the same dial. Once you make it powerful, it's just powerful on multiple parameters, which questions the way that we start looking at what is a safe model and what we look at as, how safe models are evaluated. As of this recording, those decisions and those conversations are still being held by a very small group of people sitting in one part of the world. Now, as all of us are living through this moment of unbridled intelligence, the decisions that countries make about how they engage with it is actually becoming much more important than whether these countries are building it or not. In our episode on the compute race, we briefly touched upon the fork between training and inference from a compute perspective, about the different infra, the different chips that are now needed for training versus the different chips needed for inferences. This was actually reiterated by Jensen Huang at a recent NVIDIA event, where he talked about how the inference point of inflection is here, and now they're completely dedicated to creating those distinct chips for inference, something that Google had already picked up on, as you may remember. My submission to you, however, is that the fork between training and inference is even deeper at a product level, and this is a good thing. Whether it's in terms of compute infra or deploying models locally, the inference conversation is getting completely forked from the original training compute race. This provides countries the opportunity to maximize their resources in the race that works best for them. Whether it's from a talent, use case, or need perspective, countries can choose which of the races they want to participate in, how they want to participate in, and how they want to engage in. It's no longer a single linear path. This ensures greater autonomy for the parties involved. Let's say, for example, just take the chips, for instance. Training chips and inference chips are now becoming two separate and two distinct activities, two distinct products. As we remember, the training chips are very limited in its capacity and are booked out for at least a year forward. Inference chips, however, are a brand new commodity. If, let's say, a country like India or Brazil from the emerging markets wants to say that we actually want to focus on the inference layer and we want to focus on investing in inference chips rather than training chips, that changes their access, that changes the production cycle, the products they have access to, and everybody is not focusing on the same finite resource. The entire conversation provides greater autonomy in the hands of various countries involved. Now, obviously, this is not a conversation that's happening in vacuum. The past few months have told us that in the AI world, we are more connected than ever. But the technology and the entire paradigm stands as a point where we can choose which path we take, and there are takers for all of it. As we saw, whether it's a large model or a small model focused on either training or inference, all of this has customers, has takers, has use cases that we can richly avail of, whatever we choose. It doesn't have to be the one ring that rules them all. There are multiple paths that we can choose from as countries, as markets, as individuals. Here's a hypothetical. If you had all the resources in the world, what is the kind of model that you will build? And what is the direction that you would choose? Would it be one large one for all use cases? Maybe something more niche, small, sachetized for various markets? Let me know. It would be great to hear from you as always. But with that, this is your host, Sairanya Gopinath, signing off on another episode of All You Need to Know. Catch you next time. Bye.